In this presentation, we have to talk about pH value. Potential of hydrogen is abbreviated as pH. Consider the self-ionization of water molecule. H2O gives H plus, the hydrogen ion, and OH minus, the hydroxide ions. Say H plus and OH minus once again recombine to form H2O. This is a reversible reaction and fully endothermic. Only after absorbing heat energy, H2O provides H plus and OH minus. Therefore, the rate constant value of the above reaction is Kw equal to concentration of H plus into concentration of OH minus, that is equal to 1.008 into 10 power minus 14 mole per decimeter cube. In the above reaction, the amount of H plus is always equal to the amount of OH minus. Therefore, the rate constant Kw is written as the concentration of H plus with a square, that is equal to 1.008 into 10 power minus 14. If you take the root for this, root of Kw equal to 10 power minus 7. You know the pH value. pH is given by the formula minus log of the concentration of H plus ion. Here the base is 10. This is equal to minus log to the base 10. The concentration of H plus ion in the water molecule is 10 power minus 7. This is equal to 7. If this minus ion comes forward, minus into minus plus, then log 10 base 10 is equal to 1. So the value is 7. You know that the pH value of water is 7. So we can call this one as neutral. Suppose a solution is having the pH value lesser than 7, that is acid. pH equal to 7 is neutral. pH less than 7 acidic. pH greater than 7 is base. Suppose a base is soluble, such a base is called as alkaline. If I say neutral, this implies that the number of H plus ions should be equal to the number of OH minus ions. If it is acidic, H plus ions should be greater than OH minus ion. If it is base, the hydroxide ion number should be greater than the hydrogen ion number. Now we may say that pH 7 is called neutral, which means that the number of H plus ions should be equal to the number of OH minus ion. Then only we can call that one as neutral. If there is some imbalance in the H plus and OH minus ions, then we can classify that one into two categories. One is acidic and another one is base. But traditionally we are saying that the pH value of water is 7. Is it possible at all the temperatures? No. The pH value of water is 7 only at 25 degrees Celsius. Suppose the temperature of water is increased. Temperature is increased. The pH value decreases. So here at 100 degree Celsius for water, the value of rate constant is 51.3 into 10 power minus 14 mole per decimeter cube. At this temperature, the pH value of water is 6.14. If the temperature increases, the pH value of water is decreasing. Suppose the temperature of water is reduced to 0 degree. At 0 degree Celsius, the rate constant of water is 0.114 into 10 power minus 14 mole per decimeter cube. At this stage, pH of water is 7.47. Now we may ask a question. Suppose the pH is 7, we can call that as a neutral. If the pH is lesser than 7, the solution is acidic. If the pH is greater than 7, the solution is base. At 100 degrees Celsius, the pH of water is 6.14. Can we say that at this high temperature, water is acted as an acid? No. Because a solution is acidic if there is an excess of hydrogen ions over hydroxide ions. As we discussed earlier, the number of H plus ions should be greater than the number of OH minus ions if the solution is acidic. But in the case of water, even at 100 degrees Celsius, the number of H plus ions is equal to the number of OH minus ions. Therefore, water is not having the acidic property even at 100 degrees Celsius. Still, water is maintaining its neutral property. If you consider 0 degrees Celsius, the pH value is increased to 7.47. At this stage also we cannot call this one as a base, because for a base the number of hydroxide ion should be greater than the number of hydrogen ion. But as far as the water is concerned, even at 0 degrees Celsius, the number of H plus ions is equal to the number of OH minus ions. So it is still maintaining its neutral property. So whatever be the temperature and whatever be the pH value of water, water is maintaining its neutral property. Suppose solution is made up of water, aqueous solution. At 100 degree Celsius, if you measure the pH value, if the pH value is 7, then we can call that solution as a base, because at 100 degrees Celsius, if the pH is 6.14, then that solution is neutral. Suppose the temperature is 0 degrees Celsius, a solution is made up of water. If the pH value of the solution is 7, now we can call that solution as a acidic one, because you should expect the pH value of that solution as 7.47 since it is neutral. So in this way we should understand the pH value.